Okay, so now we're going to go through a construction and proof of our construction of drawing a line tangent to circle O through point P. So the first thing you want to do is draw the line. So let's write out the construction steps. Draw OP. So let's draw OP. And then what you want to do is you want to draw circle O, but this time with radius OP. So you're just drawing a larger circle with radius OP. And now that's going to look like this if I could do a good circle. And let's see if I can make it into a circle. There we go. Okay. And then what you do is you get point you can find point, I don't know, A. Point A. So from let's say draw, let's say L perpendicular to PO through A, where this here is point A. So draw L perpendicular to PO through A. So through A. 4. So let's draw that line. Let's make it, let's say blue. Let's draw L. So I'm going to try my best here. Let's see what we get. Alright. Don't like that one. But we're going to keep it. No, let's not keep it. Let's do it again. Let's see if I can do it better. Let's see. Okay, here we go. Yeah, that might be a little bit better. Yeah, that's fine. Okay. And now we have L. This is L, let's say. Okay. And we're going to get, right, once we do that, we're going to get, let's say, point B. Okay. Get B on the larger circle O. All right. Okay. And once you have that, draw OB. So you draw OB. And then you're going to get C. So where's C? C is right here. And then last step, draw, this is C, draw PC. And if you draw a line, it might look a little bit nicer. So let's try and draw a line. Okay, not bad. Not too bad. Okay. And then now my claim is that I claim PC is tangent to the original circle, is tangent to the original circle O, the smaller one, is tangent to circle O through P, obviously. So all I really need to do is prove that it's tangent through P. Okay, let's write up this proof. So proof. So the first thing, right, we want to say is, what is it that we have? We have that, look at these two triangles, and it helps if you, of course, pull out these two triangles. So let's look at triangle POC. So let's look at POC. So this is POC, right? If you look at it right here. Okay, and then let's look at triangle BAO, or which one do I want to compare it to? So POC, I want to do BOA. So BOA. BOA. And I want to look at these two triangles here, and then I want to kind of come to a certain conclusion. So if we look, right, what should we say first? Well, AO equals OC, both radii. So then immediately, this is the same as this. And then I could say PO or OP equals OB. both radii. And then I have this is the same thing as this. And now I want to look at BO. Oh, wait. Did I mess up? PO and OB. Yep, I got to put that at the right ticker. There we go. And then let's look at AB. AB and PC. How do I conclude that these two triangles are congruent now? A, B, and PC. Do I know that those two are the same? No. How do I know? What can I say? Okay. So what do I know? I know, right, from here, right, that L is perpendicular to PO. So then this is a 90-degree angle. This is the 90-degree angle, yeah. And then I also know, right, that what do I know about okay, so now how do I show that this is 90 degrees? No, that's what I need to end with. So I've got that this is a right angle, but do I know that POC is a right triangle? Not yet. So what do I need in order to get that it's a right triangle? I know that it's tangent A at that point in AOB. What can I say now? How do I get this? Oh, I'm missing. Okay, so if we look, POC is the same thing as AOB. So then this angle is the same thing as this angle. And then you know that the two triangles are congruent. There we go. So this is an angle that the two triangles share. I don't know, angle 1, let's say. So angle 1 is congruent to itself, reflexive. So then by side angle side, so triangle, and you want to put the order right, of course. You want to say that triangle BOA is congruent to POC. BOA is congruent to POC by side angle side. And then that means that angle whatever, let's say 2 over here, let's say 2, and then let's say that this is did I mess up which one this is here? What's the right angle in this one? POC. This is the right angle, which is weird, but okay, let's say that this is 3, right? So here, right, OCP. Okay, so this is angle 3 right here, right? In the picture, it's here. And what this means is this is a 90-degree angle because the corresponding parts. So what do we know? We know angle 2 is congruent to angle 3. Let's call this 3. And then this angle 2 over here. This is 2, this is 3, right? By CPCTC. But 2 is right. So 3 is right. And then we can say that, OC or OB, OC is perpendicular to line PC. So OC is perpendicular to PC. OC is a radius. So by the theorem that if a line is perpendicular to a radius, then the line is tangent. So by radius tangent theorem, whatever you want to call it, tangent theorem, PC is tangent to circle O. And now you're done.